Welcome to the lesson on the unique features of battery electric vehicles, also known as BEVs. In this lesson, we will cover some of the specific unique features of BEVs that set them apart from gasoline-powered vehicles. Let us now delve into our lesson objectives. By the end of this lesson, you will be able to identify and explain the distinctive features of BEVs. There are many features that are unique to BEVs compared to traditional gasoline-powered vehicles. In today's lesson, we will focus on the following features, namely, energy efficiency, regenerative braking, instant start and acceleration, and one-pedal driving. The energy efficiency of a vehicle quantifies its ability to convert fuel or electrical energy into distance traveled, typically expressed as miles per gallon, MPG, for conventional vehicles, or miles per kilowatt hour, kWh, for BEVs. Energy efficiency in BEVs refers to how effectively these vehicles convert electrical energy from their batteries into kinetic energy for propulsion. This results in higher efficiency when compared to the internal combustion engines of conventional vehicles. The image to your left displays that gasoline-powered vehicles are not very efficient at using energy. Only a tiny fraction of the gasoline energy propels the vehicle. The remaining energy, as displayed in the diagram, which is around 80%, is lost due to various inefficiencies. Engine losses refer to the energy that is lost in the engine itself. This can be due to various factors, such as the heat generated by the engine and the friction between the moving parts. Drivetrain losses refer to the energy lost as the engine's power is transmitted to the wheels. This can be due to friction in the transmission, drive shaft, and axles. Parasitic losses refer to the energy used to power the car's accessories, such as the air conditioning, power steering, and radio. Auxiliary electricity use refers to the energy that is used to charge the car's battery and power its electrical systems. The image to your right displays that BEVs are efficient at using energy. Even though there are some losses, the vast majority of the energy from the battery is used to propel the car forward. The diagram displays that around 11% of the energy is lost, with 10% lost to charging losses and 31 to 35% lost to drivetrain losses. However, the brakes recaptured 22% of the lost energy and fed back to the battery. This means 87 to 91% of the original energy goes to the wheels. Charging loss refers to the energy lost when the battery is being charged. This can be due to various factors, such as the charger's efficiency and the battery's temperature. Drivetrain losses refer to the energy lost as the battery's power is converted into motion at the wheels. This can be due to friction in the drivetrain's motor, transmission, and other components. Powertrain cooling and steering refers to the energy used to cool the powertrain and operate the steering system. Auxiliary electricity use refers to the energy used to power the EV's accessories, such as the headlights, air conditioning, and radio. It is important to note that the energy losses displayed in the image are just averages. The actual losses can vary depending on several factors, such as the type of BEV, the driving conditions, and the climate. Regenerative braking is an energy recovery mechanism that slows a vehicle by converting its kinetic energy into electricity. It involves using the electric motor in a BEV as a generator while braking. The electricity generated is then stored in the battery for later use. This increases the efficiency of the vehicle by capturing energy that would otherwise be wasted as heat. When the driver steps on the brake pedal, sensors detect the intent to slow down and initiate regenerative braking. The motor switches function from drive to generator, creating resistance that slows the wheels. The amount of energy recovered depends on the vehicle's speed and deceleration rate. Note that the regeneration happens when the battery's state of charge, SOC, is low enough to allow regeneration. Regenerative braking provides an electric boost to the mechanical brakes and reduces wear on the brake pads. The stored energy can be used later to power the motors and increase the vehicle's driving range. Major automakers like Toyota, Tesla, Honda, and Ford offer regenerative braking in their battery electric models. Instant start and acceleration are two of the most attractive features of BEVs. This is because BEVs have electric motors that provide full torque instantly from 0 revolutions per minute, RPM, enabling instant throttle response when the accelerator is pressed. This differs from conventional gasoline engine cars that need to build torque through higher RPMs. Electric motors are coupled directly to the wheels without complex transmission gears. This enables precise and rapid power delivery directly to the wheels when accelerating as opposed to conventional vehicles. The instant torque allows BEVs to accelerate quickly and smoothly in a continuous and sequential manner. Electric cars can go 0 to 60 miles per hour in under 4 seconds, providing an exhilarating driving experience. This feature can prove valuable in various scenarios, including entering a freeway, overtaking another vehicle, or navigating congested traffic. One-pedal driving allows the driver to slow down and bring the car to a stop using only the accelerator pedal. This is achieved through regenerative braking, which captures kinetic energy when the driver releases the pedal. When the driver lifts off the accelerator in a BEV, the electric motor functions as a generator, converting the vehicle's kinetic energy into electricity. This electricity is then stored in the battery. The amount of energy captured depends on how quickly the driver releases the pedal. If done swiftly, the car will decelerate more rapidly, capturing more energy. One-pedal driving can significantly enhance the energy efficiency of a BEV by reducing the reliance on the brake pedal. When the brake pedal is used, the vehicle's kinetic energy is converted into heat, resulting in wastage. However, with one-pedal driving, the vehicle's kinetic energy is converted into electricity, which can be stored in the battery for later use. This feature can also extend the range of a BEV and improve its overall efficiency by up to 5%. It's worth noting that not all BEVs come equipped with one-pedal driving. Some offer it as an optional feature, while others do not have it at all. The benefits of one-pedal driving include enhanced energy efficiency, extended range, a more relaxing and less tiring driving experience, and reduced wear and tear on the brake pads. Now, let us review what we have covered in this lesson on the unique features of BEVs. BEVs demonstrate superior energy efficiency compared to conventional vehicles because they convert energy from the battery into motion with minimal waste. BEVs utilize regenerative braking to capture kinetic energy when the car decelerates or comes to a stop, subsequently storing this energy in the battery, thereby extending the vehicle's range. BEVs can deliver maximum torque right from the beginning, enabling them to accelerate quickly and seamlessly. Another distinctive feature is one-pedal driving, which allows the driver to decelerate and bring the vehicle to a halt using only the accelerator pedal. This is accomplished through regenerative braking, which captures kinetic energy when the driver releases the pedal. Thank you.